Now we'll explain the modification of ultimate bearing capacity for water table. To discuss the effect of water table on ultimate bearing capacity, consider the figure. Consider this figure. In this figure, shallow foundation with width equal to B and depth of foundation equal to DF. The water table is located at a distance D from the top. We have three cases of the effect of water table on the ultimate bearing capacity. In the first case, when the water table is located between the top of the soil and the base of the foundation, between the top and the base of the foundation, D is greater than 0 and less than DF, depth of foundation. In this case, the effect will appear in the second term of the ultimate bearing capacity and the third term. Remember, the ultimate bearing capacity equal to ultimate bearing capacity equal to C and C plus Q and Q plus 0.5 B gamma and gamma. In the first case, when the water table is between the top, between the ground level and the base of the foundation, the effect will appear at the second term of the bearing capacity and the third term. In the third term, gamma will be gamma dash. Gamma will be gamma dash, submerged unit weight. And in the second term, let us assume the distance from the water table to the ground level equal D1, and the distance from the water table to the base of the foundation equal to D2. Q dash is the surcharge, of the soil, and equal to gamma dash multiplied by DF. Therefore, Q dash will be D1 multiplied by gamma plus D2 multiplied by gamma dash. Case 1. The water table is located D is greater than 0 and less than DF. Then Q dash in the second term equal to D1 multiplied by gamma plus D2 multiplied by gamma dash, the second term in the ultimate bearing capacity. And gamma will be gamma dash in the third term of the ultimate bearing capacity. This is the first case. The second case, when the water table is located below the base of the foundation to a distance equal to B, the width of the foundation. It is located between the base of the foundation to width B below the base of the foundation. At any location here, the water table, if the water table here, the water table here, but not far from the base of the foundation by distance greater than B, not at this distance. If it is located between the base of the foundation and width equal to B, this is the second case. In the second case, the effect will appear when D greater than 0 and less than B will appear in the third term. The first term will be gamma multiplied by dF. Why? Because this surcharge here will depend on gamma, unit weight of the soil, because it is not saturated. The soil here is not saturated, since the water table is located below the base of the foundation. So Q equal to gamma multiplied by dF, while gamma in the third term equal to gamma dash plus D over B, gamma minus gamma dash, D over B. D is the distance here. This is the distance D. D over B. D over B multiplied by gamma minus gamma dash. In the third case, when the water table is far from the width, far from the base of the foundation, is located at a distance greater than B. For example, here, greater than B, there is no effect on any term of the ultimate bearing capacity. To explain that, remember the assumption of the failure surface by Terzaghi or even by Meyerhof. There is a triangular elastic Rankine and then log spiral and then passive Rankine. 3 zone, the first zone, the second zone, the third zone. Remember, this is B over 2 and this is phi. This distance will be approximately 0.5 multiplied by B tan phi, or based on the assumption of Meyerhof, it will be 0.5 B tan 45 plus phi over T2. Since the water table is far from the region of the shear stresses in the soil, there is no effect on the ultimate bearing capacity. It depends on the distance below the foundation that will be affected by the stresses. Now, there are 3 cases of the effect of water table on the ultimate bearing capacity. The first case, when the water table located between the ground level and the base of the foundation. The second case, when the water table is located at a level between the base of the foundation and at width at B below the base of the foundation. And the third case is far from the base of the foundation and the distance greater than the width of foundation B from the base of the foundation. And the effect will be at the second term and third term. The question here, who is the first author, who is the first researcher who studied the effect of the water table on the ultimate bearing capacity?